Thank you for coming to our presentation. So, hands up here who likes baseball. Okay, we got a nice surprise for you. It's not me and it's not Chris. So going to do quick introductions. My name is David Kearns. I am an offering manager for IBM. The rest of the world calls it product manager. And I work with the data science tools in the analytics portfolio. We also have Chris Code. He classifies himself as a storyteller. In other countries, it's called something else, but we'll go with storyteller. We also have Aaron, who's a chief machine learning scientist, and we also have Ari, who is Mr. Moneyball. Okay, so I'm the chief of nothing. I have a 3-year-old girl, so I don't even get to be the chief of my own house. So we're going to have a fairly interactive session. There's going to be 4 speakers, but hopefully we don't lose you, and it's quite interesting. So Moneyball. So Moneyball was coined via Michael Lewis's book, but probably more when it was in the movie with Brad Pitt and Jonah Hill. So myself and Chris are kind of like the Brad Pitts, and Aaron and Ari are Jonah Hill. And we're the Brad Pitt after the Angelina Jolie breakup, okay? So, but what you're trying to do is using data analytics and artificial intelligence, okay? And what you're looking to do is find the best baseball players to build an optimal team and to win championships. And when you make playoffs and when you make championships, your revenue increases. So if you look at today in any organization, so Moneyball aside, you've got the following challenges. So data-related challenges are hindering 96% of an organizations from taking full advantage of AI. So this should be resonating throughout the conference with you. If you don't have good quality data, and if you don't have a big breadth of data, you're going to run into challenges with taking an advantage of AI, right? So data is the key to getting good AI within your organization. And as you go, data systems don't do AI, and AI technologies don't do data. So generally, you see a lot of tools within an organizations. And you might have a data scientist in the corner of the room with one tool. You might have the data engineer with another tool, and generally they're not integrated. And they're sharing PowerPoint or sharing Excel spreadsheets in like box folders. And sure, we had a SharePoint technology in the 90s. It's not the most sophisticated way of doing projects, especially when it comes to AI. And as a result, 80% of organizations face collaboration challenges due to silos. Okay, if you start off poor, the problem just actually grows and grows and grows, where you'll get to the point where you kind of don't even know which way a line of business has gone. So how does Moneyball relate to business? So diverse data sets living in distant systems and formats, and Ari's going to talk to you a little bit about that. Collaboration across consistent data and analytics to power predictive insights and capabilities. Okay, so that is key in any business. And what you want is AI and machine learning to be built on engineered features, analytics ready for data. So what you want to do is get that data prep as quickly as possible so you can start building your models and gaining insights and actually building accurate predictions. And as we all know, whoever here is programmed in C++, Java, or Python, Ruby on Rails, the technology keeps coming and coming and coming and coming, right? So you've got to have competition drives need for innovation, fast and clear ways to consume these insights, okay? You can go down a bit of a technology hole, okay? So you've got to have a good plan. You've got to get the technology together. But if you don't have your team set up properly, you could actually go off course very quickly. So what did we want to do? So just take you back a bit. Why I kind of started this Moneyball idea was I did my final year project in the late 90s was on artificial intelligence, and it was fingerprint recognition system. And the problem back then is there was no such things really as GPUs. It took forever to train the model set. So whilst it was a very good project, the results weren't great. And then I wanted to make money in my life, so I decided to go and get a job as opposed to stay in college for so many years. But what has happened now is with the likes of NVIDIA and that, we have GPUs, so we have the processing power to do all these big, massive calculations. So we're now actually, AI has been around since the 70s and the 80s, but we now have the ability to make computational power that gives us the ability to build these models, to train them very, very quickly and not wait weeks or months or years to train models, which it was like in the 70s, 80s, and 90s. So we also wanted to work with a distributed set of data stored in different repositories. And we're going to talk to you a little bit about that data as we go on, because the data is key, as we said at the start of the presentation. And what we wanted to do is build consistent data and derived attributes. So when you're working, you'll have a set of data, right? But looking at data, you can actually get more insights from that data by maybe doing some simple calculations. And Ari will talk to you, about a specific set of examples. And what you want is, so there's Mr. Moneyball, right? But let's say he was hit by a bus. You don't want his not that you're going to be hit by a bus, are you, right? We're going to take good care of you. But what you don't want, driverless car based on AI, yeah. But what you don't want to do is to lose that domain expertise. So if you hire a data scientist, you pay them 200 grand, they work on something for 2 years, then they find a better job or a job they're more interested in, they leave, you have no idea what they've done, expertise is gone. So it's not very useful for an organization. And if you're a business, you've got to keep the knowledge, but it has to be democratized. People within the organization has to know it. They have to understand what it is, what it was for, and what it was applied to. Okay, and that's why you want to operationalize your machine learning and your AI. So, 2 sets of data that we use. Has anyone ever heard of the Layman database? Okay, a couple of people. So it's a free database that anybody can get down. It is basically a highly aggregated data set for every single player that has ever played Major League Baseball. They'll have an entry in this database, even if they've only played 1 game, and there has been some people like that over the years. And as I said, it's very aggregated. So it'll have their ERA for a single year. That's it. Okay, it'll have their batting average for a single year. It's very interesting. And when I met Joe, who works with Aaron in H2O, I said to him, this is my idea. Moneyball was statistics. Let's bring a good example to the AI, right? Because I wanted to get back into it. I wanted to get back into machine learning, but I couldn't find any good examples. So I thought doing this project would be interesting. So we start looking at the Layman database. But at that point in time, we met Chris, and he goes, hey, I have an idea of doing the exact same thing. And we were doing a presentation at Think, which is an IBM conference. And then he says, oh, I have a guy who knows something about baseball. I was like, okay, that's great. Probably knows more than me. The guy I'm working with is living in London from Hong Kong, doesn't know baseball. I've traveled to the States loads. I've seen games. Hey, I know a little bit. He goes, his name is Ari Kaplan. So, any Cubs fans? Okay, so Ari was tasked with building the analytics departments of the Cubs. So people were saying they were cursed, they'll never win. Well, actually, all they needed was really good insights, really good analytics, and you can build a team that can win the World Series. Or you can also rob Theo Epstein from my team, the Red Sox. But anyways, so Ari has worked with a lot of baseball teams over the last 30 years. He's currently a special consultant with the Baltimore Orioles. Anyone heard of Fred Clare? Okay, so he won a World Series with the Dodgers, and he kind of recruited Ari from Caltech to build an application that he did in the 90s. So we had that very free database. We thought we were great, and then Ari came along and said, actually, do you know what, I kind of have a better database. So from about the year 2007, 2008, Major League Baseball has the ability to give you a data set for every year, and it classifies every single pitch thrown in Major League Baseball. So imagine you're going from layman, highly aggregated, to every single pitch. Who was on base when that pitch was being done? What was the spin rate of the ball when it was thrown? What was the height upon which it was released? What was the speed upon it was released from the pitcher? What was the speed when it reached the plate? So as you can see, this is a very, very big data set with a lot of huge information within it. Okay, so we kind of talked about this. This is the very bad way of doing machine learning or AI, because what you're looking at is a very siloed way of doing it, or lots of manual ways of doing it, a lot of passing and emailing of spreadsheets. All of this is a bad way of doing things, right? You're looking at different data sources, small data sets, okay? Somebody says, oh, I have a data set, I'll share it with you. They're not necessarily taking it from a database, whether it is a warehouse or an event store. Okay, they're doing a lot of manual data prep recode, and no model reuse. So that's basically one person on the laptop hacking away, building it together, producing a model, but never actually saying, well, I've produced this feature set, it's very good, maybe I can share it with the rest of our organization. We're talking about baseball, but what happens if you were doing banking? What happens if you're looking at customer churn? You know, that could be a very good data set for you to share maybe with a line of business that shares similar customers. Okay, and then they're doing manual model tests and specific expertise. But hopefully another thing that's resonated with you at this conference is, where AI and machine learning is going, is you have to be able to explain your decisions to people in certain industries. So if I've refused you a loan, I have to give you the ability. I cannot just say, sorry, the computer said you're not viable. Well, why? Well, because the computer said you're not viable. That's not good enough, right? So you have to have full traceability from your decision and what did you use to make that decision, okay? So that is where data governance and model traceability is extremely important. If you don't have that, how can you be consistently making sure you're making good decisions if you're not sure what your data is, where it came from, and how did it trace to the decisions that were made? So this is not a good way of doing machine learning in an enterprise. If you're doing it this way, it's a bad way, and what I'm going to do is I'm going to pass over to Chris now, and he's going to show you the way we approached it to give an enterprise view of machine learning in an enterprise.
Yeah, so as David said, you know, and you could probably tell he's got that funny accent. So he's across the pond, and he talked about Joe, who was over in Asia. So our team was very diverse and very globally spread. So we started thinking about how we're going to actually organize this, especially when Joe and Aaron don't know that much about baseball. So how are we going to actually encapsulate the knowledge of Ari and be able to spread that, so that way we could actually build the analytics and the derived attributes very quickly without having them to recode every single time. And when we continue to get more and more data sets as it relates to baseball, we don't only look at the MLB players, but we're also trying to find the up-and-coming rising stars. So those are the folks that are in the single season leagues or are in Japan. Or most recently, we just got a data set with the Korea data model, and that's happened in the past 2 months. So you want to be able to bring on that data set very quickly on a data platform that is enterprise ready and ready to go. And that's why we partnered with IBM and H2O to kind of bring this together. But as we bring in that new data, we didn't want to have to recode those analytics over and over again. We're still trying to predict the same thing, which is player performance, and for a batter that might be ERA, or for a pitcher it might be ERA, and for a batter on base percentage, of course. And we'll get into a little bit about how we did that. But we wanted to be able to reuse those analytics as we brought on that particular new data. So we started thinking of this in layers. And if you look at the data layer, and then we can take it up to the analytics layer, where we no longer have to redo those table joins and all of that data join over and over again, because we built a logical data model or a semantic layer that made it really easy to understand each of those codes. So that way, Aaron wasn't doing the same work that Ari was doing to build those derived attributes. They could now be reused and quickly operationalized in other tools like a data science platform. And the data science platform that we'll show you that we chose to use was IBM Watson Studio, and we used RStudio within that in order to bring that together, find those derived attributes very quickly, and then use that data science platform by importing our other partner, H2O, to find the machine learning models. So that way they could feed the machine learning models, because we know that it's not only the data that's going to drive those decisions, but also whatever the result of that machine learning model is can then be reused over when we bring in additional data sets, or it can be grabbed by other tools to be operationalized very quickly. I'm going to turn it over to Erin. She's going to talk a little bit about H2O and how she was able to actually take both the data layer and the analytics layer and then use it up in the application layer within IBM Watson Studio.
Yeah, so as Chris mentioned, H2O is a machine learning library. It's an open source library, and it can be used in R, Python, Java, Scala, even from a GUI. So it's pretty flexible, and in this particular case, we use the R library. So within IBM Watson Studio, you have RStudio running. You can just basically load the H2O library. And then in this case, so H2O has a number of different algorithms. But one of the newer features that we have, and this is the project that I work on, is called AutoML. So that's the name for basically a function that automates training and tuning all these different models, and with the goal of just kind of getting the best one. So all you really need to do as a data scientist is, if you want to use the other functions, you can, but if you want to just basically take your data set and point it at, point H2O at your data set, you can just sort of click a button and it trains a bunch of models for you, and that's kind of what we've done here. So, so then that kind of frees up your time to focus on other things like augmenting the data set, bringing in different resources. So maybe you have some open source data. So let's say this layman database that's maybe not great, but it's getting you somewhere. But if you have access to other tools where you can easily pull in a bunch of new columns that is either proprietary data or something that a colleague has created themselves and shared through the AMP system, then it's very easy to use. So I guess with AutoML, the focus is more just getting your data in the right place and clicking a button to press, and then you're good to go. Yeah, you're going to explain.
So what we're going to do now is, while slides and all that are wonderful and beautiful, what I'm going to try and do, and hopefully it works, is that we put together a Shiny app. Now, against my better judgment, there is some Yankee players in there, Matt, so I wanted to skew the date as well, but they wouldn't let me do that either. But anyway, so how do I get rid of this thing? How do I get rid of that? Sorry. Ah, perfect. Okay, so what we did is we put together a Shiny app, and what this has is it has every pitcher and batter in Major League Baseball that has played. I think the cutoff point is we made sure they played at least 15 games, okay? And if you go to the pitching, oh, look at that, there's a Red Sox pitcher there first. It's not shocking given I'm a Red Sox fan. So what I'm going to do now is bring Mr. Moneyball, Ari, in, and he's going to kind of walk you through, some of these predictions. And he's also going to kind of talk to you about how this information is used day to day. As I said, Ari's been working in Major League Baseball for 30 years. In all those times, he's either been assistant to the assistant of the general manager, but then he went directly to special consultant to the general manager. So I guess, Ari, if we just maybe start talking about Chris Sale and just talking about maybe his ERA and maybe his whip and just the difference between the layman and your data set.
Sure, yes. So being domain expertise, I should say thank you for that kind introduction earlier and then. It's been a big honor to work for 30 seasons in Major League Baseball, which has gone through the whole life cycle of machine learning and AI, both from the computational standpoint to the data collection standpoint to finding actionable insights, and having all different roles, Major League Scout as well as analyst. You're really trying to solve some problems that are similar to business. Being the assistant to the GM, you're trying to do predictions and classifications. In this case, predicting how will a player perform based on prior information. Classifications are everything from how do you identify what a pitch type is, or how likely is a player to be injured. So that's a common theme through this conference has been the more features or the more derived attributes that you have, the better it is for ML. So you can see there's, I'll come over here, a couple different lines. The blue line is the historical data, what's happened in the past, 2010 onward, that's what we trained it on. And then the green is the layman data. That's like highly aggregated information. One line of information for every season on a player. How many home runs did they hit? How many plate appearances did they have? And that's good, that's predictive. But going along with the theme of more features, better predictions, we now introduce the orange, which is the ARI database. Every single pitch, we're talking 4 million data points, almost 1 million per year at the major league. That includes, it's like putting on glasses, more features. For every pitch, what's the XYZ of where it's released, the spin rate, when the ball's hit, how hard was it hit, exit velocity, launch angle. So with that, the predictions are better. And then we're also talking on the theme of encapsulating domain expertise, which is another theme in this conference. It's machine learning, but also guided by the experts. So I know, having been in baseball, there's certain, like a threshold. If batting average or OPS is one thing, but how do they do against the more challenging pitches? So if a pitch was 93 miles an hour or harder, that's what I really want to know, and that could be better prediction than just the generic overall OPS. So in this case, we use AMP to create these new derived attributes, but that's the way you encapsulate the knowledge. Another one could be the velocity of a pitch is 92 miles an hour. In and of itself, that's helpful, but to predict future performance, sometimes it's a derived attribute of, is the velocity decreasing? Did they used to throw 100, then 98, 94, and now it's 92? So like, what's the year-over-year trajectory? So all of those is a broader data set and feature set going across. And you can see these are not insignificant differences. In Chris Sale's case, it's actually a great case. It's our home player, our default player, but we're just looking at how he performed this year, and it was under 2 for the ERA. So it was towards what the richer data set predicted, which is exactly what we wanted to achieve.
And then at this level, right, okay, there's the big players everybody knows, right? But obviously, Ari spends a lot of his time not just looking at the big players everybody knows, but when it was in March and it was just before trade deadline, you had us look at certain players. I think it was like John Lackey was one, or
yeah, it was still spring training, and it was a unique case where there's really high quality pitchers, Jake Arrieta, Cobb, Lackey, and others that were still available even though it was spring training. So yeah, real life case of who's forecast to perform the best.
So if you look at John Lackey there, somebody might say, oh, well, in 3 years' time, he's going to be a lot older. You know, is it really worth an investment? But as you can see here, well, Ari's going to explain it better than me. You know, there's still value in that player, right?
Right.
So this is kind of where, this is kind of key. You know, this helps. You're never going to replace an Ari Kaplan, right? And I went to my first baseball game yesterday. It was to Oakland A's, home of the Moneyball, so it resonated very well. And sitting beside Ari is like sitting beside the Oracle. And they have a machine learning based algorithm that classifies the pitches. And it was interesting to see Ari disagree with some of them. So it was very good. But this kind of would help supplement your decision-making process, right?
Exactly. And in addition to my work with Aginity, I'm consulting with teams, so working with a general manager to help make decisions on which players to trade for, free agents to sign, what are the risk factors involved. I think almost everyone raised their hand, they like baseball in this room, but if you go to any of the public websites, they only do 1 year prediction. What's the forecast for 2019 isn't even up yet, it will be. But we predict many, many seasons into the future, which is quite helpful.
Yeah. And just maybe a quick, how would all this be used in your day-to-day? Like, you know, when would you move to say something like this where you're looking for predictions or where you would just be looking for like general information? How has it moved on in the 30 years, I guess, since you started this?
Yeah, well, when I started, there was no internet or emails, and we were talking beforehand. I worked for the Orioles back in the 80s with Earl Weaver. One of the inspirational things is he came up with the lefty-righty split on an index card, and they said, you're ruining baseball, kind of like in the opening keynote, when the rocket ships were being designed, it'll never work. Same thing, it'll never work, these splits don't work, but he said, the data shows me if I do this action, bringing a lefty or righty in, it'll help me win games, and now if you don't do what that data says, then you're the loser, so to speak. So the other thing to emphasize is these differences, one win is worth $4 to $5 million. So for just one game, sometimes 6, 7, 8 million if you're close to the playoffs. And so these are pretty significant information that you have. So to answer your question on what you do day by day, a couple times a year you're doing big free agent trades, but every day there's something called the waiver wire, where you can pick up or trade minor league players, people that are on the borderline, people that got injured, that might be a reclamation project. And this type of information will tell you the risk factors involved, as well as is it worth the asset that you're getting greater than the assets you're giving up, which could be money, it could be performance within the game. So every day, decisions like this are being made.
Yeah. And then, Aaron, I'm just going to call on you. So when you're building these models, I talked about earlier on, how do you explain these models and how they've helped? So with the concept of Lime, you have the ability to kind of rate the features or see what contributed or contradicted to your prediction. So Aaron is going to explain this infinitely better than I can.
Yeah, so I guess on the theme of maybe sometimes not trusting the AI, or maybe just trust but verify, or whatever that term is. So Lime is a method that allows you to look inside of the black box, so to speak. So it stands for locally interpretable model agnostic explanations. And the model agnostic part is actually kind of key. So what that means is you can use the same method on any machine learning model, and that's actually extremely valuable. Because in something like AutoML, the goal there is just to find the best model regardless of what it is, if it's a random forest, a deep neural net, or whatnot. So we could apply something like Lime to whatever model is found during the AutoML process, and then look at individual predictions. And so instead of looking at the model in general to see which features are important, whether it's the height and weight of a player or how many games they've been playing in, you can look at a particular player and see what features are important to them and that prediction that you're making here. So this is batting average, I guess. So in this, I think it's very hard to see sort of these are names of features here, but basically there's a feature here where what's highly predictive of there was another one where we were looking at home runs, and basically the weight of the player is actually highly indicative of and for this particular player, that was one of the features that predicted whether or not they were going to hit home runs. So if they're a very heavy person, they probably have a lot of muscles and
or strong.
Yeah. So anyway, this using, especially with AutoML black box methods, it's good to have a tool to look inside and kind of see what's going on there.
Excellent. So, yeah. Perfect.
So in order to kind of help out Aaron and Joe be able to do all of their machine learning, what we did was we were able to provide those derived attributes and those analytics that Ari created directly in the data science platform by using that analytic layer, our Aginity AMP, our product, that allows them to go through and find each of those derived attributes very quickly, bring them into the data frames, and then actually feed those machine learning models. So you can see here how we're now browsing the analytic layer live directly within RStudio, and you can select different assets, and you have a nice description on what each of these analytics are that Ari created that she can bring over directly into RStudio after the machine learning is done and imported in order to understand which of these features and which of those feature sets are that are actually driving each of these predictions. So you can think of this as every calculation or every piece of code that you actually write, whether it's just the sum of sales or it's some flag on a particular database, that's very important, and that's rework that you don't want to have somebody redo over and over again. So having Ari be able to do this and provide this for both Joe and Aaron across different places and all the different data sets made it very valuable, so that way she could actually quickly feed and understand what each of those are. And we were able to encapsulate Ari's knowledge from those 30 years of baseball directly in here, so that way we could understand what the predictions are going to look like going forward, and he could make million-dollar decisions, literally, right? So just kind of wanted to show you how we did that. And if I go back to PowerPoint. So that's great, right? So and how it's all kind of coming together from the demos, but really kind of what did we learn as a team as we kind of went through this, and what can you take home from an enterprise level, and how can you actually be able to do this within your own business and your own organization, right? I mean, that's the big thing. And then the number one thing that we learned is we had a diverse team with specific skill sets, right? I'm probably the only one that didn't actually write code on this project. That just kind of helped write the story and what that means. But it's important to have that, and I was able to push Ari from just a baseball fan point of view, saying like, well, what about this analytic or what about that analytic, and get his expertise. But we have the domain expert there, and they could provide the context first, and then you have a project manager and then the data scientists that each are doing all of their own specific skills. And our data scientists, remember, knew nothing about baseball, nothing at all. And so we're trying to get them up to speed and understand what that means and then what they could actually use so they could explain it later and then push this forward. And if we take a look at that, we've talked a lot about this and you've heard me say it. That's encapsulating that domain expert knowledge. So as you kind of think about that within your enterprise or on your team or your department, who is that person that you go to on a regular basis to find specific analytics? Or which team do you go to? And is that easily shareable? Are you able to grab their, get their work and take their analytics and either build upon them or quickly operationalize to do tests in your business, to drive the business value, to find the opportunity? What we found is if you make this easily accessible across the enterprise for the teams, in order to do this, you can quickly get each person to focus on their specific skill set that they're really good at. So Erin with AutoML, and plus she likes being able to find and do the innovation more so than all of the data prep and all of the recoding that you typically see over and over again, and then really kind of provide the value across the enterprise for each of the teams and departments that are there. The other thing that we've learned just kind of in general in working with the team is that there's similar analytics across use cases. So if you think of an enterprise, there's a lot of analytics that, again, are recoded over and over again. And 80% of those analytics are highly similar, but today we would make a bet that 100% of them are recreated over and over again. And we would have done the same thing as we got new data from the spring leagues, from Korea, from Japan. We would have said, batting average, do this against this data set, and then try to find a way to munge it all together. Luckily, we took the layer approach, and we were able to quickly do that across the logical data model, and then add those new data sets and operationalize those analytics very, very quickly. Lastly, as you've heard at the conference, it's all about how can I actually leverage those features? And these features enable AI and ML. So whether that's a person in one department or another department, or even on teams as Ari is working with other folks in the actual baseball industry, or you're working with other people within your enterprise, encapsulating those and having a bank of enterprise with features that you can quickly reuse instead of recoding them over and over again is really going to power the innovation behind the artificial intelligence and ML projects that you're trying to do. And I think Erin would back me up on this as she continues to work on a lot of her enterprise projects on a day-to-day basis on what that actually means. So you're probably wondering, hey, you guys all got together, what actually happened? So our final project result here, when we first started this in February, we actually led to a $20 million trade during spring training earlier this year in March. So Ari actually used this data, and I can't give you the name of the team, but they were able to pick up a player for $20 million that produced results for the Baltimore Orioles. And that's not just producing results for them, but it's also going to come in memorabilia. It's going to come in ticket sales. It's going to come in a lot of different things. If you just look at baseball salaries alone, you're talking about $6 billion across baseball. Now add on the ticket sales, add on the memorabilia. That's a pretty good sized chunk of business. I don't know how big your enterprises are. If you're, maybe you're on the smaller side, the startup side, maybe you are a $6 billion business. But even what we're seeing here is relating to how you guys can take it back to your enterprises and actually take what we learned and implement it very quickly. Thank you very much. We'll open it up for questions and answers. Yeah.
So sorry, just while we're waiting, I think you stand at the podium and ask, or the microphone, ask a question. But just so I talked about me trying to get back into data science a couple of years ago, working with Joe. So obviously Ari's database is proprietary, you couldn't share that, but the layman database and some of the code that Joe did and Aaron did is up there in that GitHub repository. We're going to put this up on on the O'Reilly downloadable site, and you'll be able to get it. Another thing just is there's our handles. Feel free to reach out to us, whether you want to talk to us about baseball or our products. We're happy to talk to you. If anybody's really interested in sports, here's some very interesting podcasts. Not self-promoting, but myself and Ari did a pretty good one, if you want to listen to that. But also there's one there on that dreadful team, the New York Yankees. And then there's also Sam Charrington did Twimmel AI, and he did a series of podcasts with people doing sports analytics from a machine learning or an AI standpoint. So, and then if you want to learn more about our products, there they are. Feel free to follow those links and learn a bit more about those products at an enterprise scale. So at that point, fire any questions at us. Yep.
So in a game with slumps and streaks, how do you handle those anomalies versus trends in your analysis?
So that's so the question is like anomalies and streaks, and how does that handle? That's an excellent question. In fact, I was talking a gentleman, Ben Cohen from the Wall Street Journal. That is such a fundamental question in sports that he's writing an entire book on, does the hot hand exist in sports? And it's interesting, like for a while, people say it exists. Then the consensus in the analytic community was there's no empirical evidence it exists. And now it's leaning back towards it does exist. That leads to the bigger picture of behavioral science. And it's not just in sports, like you talk about CPG and somebody's hungry, they behave differently in a grocery store than when they're not hungry. Or your kid got a cut on their hand and you have to buy a Band-Aid. Are you going to say yes to a $15 box of Band-Aids or $3? So the hot hand, some people, of course the answer with everything in real estate legal terms is it depends. There are people that do slump, that do have physical, non-optimal performance, as well as people that do perform well and people where it doesn't get effects. So the answer is it depends that yes, there are the hot hand proverbial for a subset of the players. But we do factor that in. The World Cup, and not just in baseball, it's like how do you optimally establish a team later in the game when fatigue's starting to set in, who gets the fatigue, who doesn't, when you substitute in, does get a big factor in certainly when playoff time comes.
Yeah, so I don't know, so I'm from Europe, so this resonates with me and it might fall flat here, but does anyone follow rugby or understand the game of rugby? So if you ever look at soccer coaches, they're down on the sideline screaming and shouting. If you ever look at rugby, the head coach is never on the sideline. He's up in a booth with about 5 laptops and they're looking at GPS device, player statistics, real-time information to make decisions on the team. They're not down by the sideline. They're up there looking at the game, looking at the information that's feeding. So this type of information, this type of analytics is just becoming more and more prevalent in the game. Benfica, who are a small team, but they need to make the Champions League every year, use this type of analytics to identify players that they can sell on for massive, massive value. And one of them would be, I can't remember the name, David Luiz, or Rui, the Chelsea player with the mad hairdo. They sold to Chelsea for 50 million, but they bought him from Brazil for practically nothing. So these decisions, these analytics are key to sports businesses. So they should be no different than your business, okay? So just while we're here, we kind of skipped over this, but this is the AutoML. So whilst you can get knee deep in your algorithms and writing your own algorithms or whatever, AutoML here, this is how we invoked. Once we did all the data prep and we worked in Agility, and Ari and Chris put all those features together, and we all get them into the set that we wanted. This is some of the work that Aaron and Joe would have done to invoke the H2O AutoML, okay? And then it did a lot of, actually Aaron, if you want to just talk for a minute or two, what happens after this step?
He's got a question.
Oh yeah, go for it.
You've got the dream team.
Yeah.
You've got your domain experts and all that.
Yeah.
We've heard in the industry that the average data scientist produces a model one every 18 months.
2 weeks.
We
or so.
smashed that time limit by a country mile and then some. Yeah. So if you talk about the team getting organized, we talked about myself and Joe talked about the idea in Munich, and he went, "That's a great idea." He came in September. Him and I spent 2 days together. We kind of hacked together a cluster vision of the pitchers and the batters, and it was great. And then we kind of said, "Okay, we're busy in our lives. Tink isn't until March of next year. Sure, let's wait." And then Ari came on board. So ultimately, from the team getting together in the first week of January and deciding, hey, what are we going to do? We just didn't jump into it. We planned it. We asked Ari a ton loads of questions. We worked with Chris to get the story together. Then we got Joe up to speed on the data. You're talking about the project to delivering it being 2.5 months. So that smashes 18 months. Yep.
I had a question on how team work plays in your modeling and analytics. For example, you predict that player A is very good and player B is very good, but your data is from different teams, so maybe they together don't play well. So how do you model that kind of stuff?
Yes, that's a great question. To repeat that, it's a lot of the data is kind of individual focused, and a lot of the way sports are played, baseball, but certainly in other sports, it's about how teams interrelate. So, for this model, that's actually living in some of the answers where the font was too small to see. So what team you play in, what stadium you play in, baseball is unique in that if you hit a lot of balls deep to left, one stadium like in Boston, it could be very advantageous to you if you're a batter. If you're a pitcher, that allows a lot of fly balls. Colorado might be one advantage, and Boston a different. But then, so that's what we incorporated in our models. And then for extra care, when I looked to trade a player, I hate to bring up Stanton, but that was the other example we brought up. He was in Miami, where he was pretty much one of the main, if not the main players. So the opponents could pitch around him, not give him anything easy to hit. It's okay if he walks. But when you go to a team where the batter before you and after you is exceptional, they're going to have to pitch to you more hittable pitches, so he could excel even more. So that's like one advantage offensively. And then defense is a whole nother topic, but how do defensive players interact is a big discussion and focus in analytics. But yeah, it's behavioral science, it's team play, it's how different, what we call assets, but they're humans, interact is a big part of it.
Yeah, like if you remember Moneyball, it was like they changed it by saying it's on base percentage, first base. That changes everything, right? So that was really just looking at one analytic. Now, it's a movie, so they probably dumbed it down a whole lot, right? And there's a lot more to it. And ultimately, I remember we were talking over dinner in Las Vegas, and Ari said with batters, it's a little bit easier to predict, but with pitchers, it's a little bit more difficult because there's so much more to it, right? And I think you said it's about a third. One you'll get right,
Yeah.
one you'll get wrong, and then one will be even better than you thought, right? So, but that's a random, right? But maybe using analytics like this, you'll get to those people kind of quicker. Another thing that we did, which we couldn't really show here, is we did augmented reality. So we were able to build visualizations like 3D charts, which basically looked at the ERA of many pitchers, looked at their salary, and then we were able to start even putting 6 pitchers beside together and looking at their history and their predictions going on 3 years. So we were able to look at individuals, compare them, and then kind of see who they played for, and kind of help us with that. Ari, the royal we, him, help him make those decisions, right? So it's about gaining as much information as you can. It's a sports team. You could go out and break your leg on on a bad pitch. You can't legislate for that. But what you want to be able to do with the information that you have in your organization, okay? If you have that information, you have to know what it is and how it can contribute to your decision-making process. So that's kind of key. There'll be some elements where you may not be able to be as quantifiable as you would like it to be. It may be more qualitative, but you still have to have that in your whole decision-making process. And that's the same for any business, right? You cannot, right now, you cannot produce a model that's going to be 100% successful. It's going to be right 100% of the time. It doesn't exist. But what it will be able to do is improve things, be right more times than it's not, and basically improve something in your organization, whether that's customer churn or whether that's a chatbot that gives a better customer experience. These things can be used to build a better experience for your organization, or to do better predictions as to where you want to invest your money.
So we're way over time, but we're on break, so.
Yeah, we can stay and yeah, yeah.
There seems to be
Fair enough.
a lot more, there's more and more data over the years on the results of a play. So where the pitch ends up, the spin rate, the launch angle, the location. Is there, and it seems like the majority of people are using that type of data to predict future results. Is there any data around the mechanics themselves, the pitching mechanics, hitting mechanics,
Right.
mechanics that will determine that has any prediction or any kind of insight into some of the decisions that you're making?
Sure. So repeat the question is that started out actually here in San Francisco with Sport Vision, being able to track all the data that we used in this, and then it was taken over by StatCast, TrackMan, where they track everything that's happening on the field, multiple terabytes of data per game, and now the next thing is this mechanical type of information. So there have been third-party companies like Baseball Info Solutions and others where they have like a room full of interns watching video and saying what their bat speed is, what the angle of the swing is, where their hips are, where their elbow is, and recording that type of information and then selling that data to the teams for money. And now, actually the Astros are the first team, but now a lot of teams are doing concepts we see at this conference where they're looking at video and being able to say, this is an elbow, this is a wrist, this is a hip, this is a neck, and see where the movement is and sync that up to time. So you get an automatic ingestion of the mechanics.
Yeah.
And that's really the hard part. And then the second hard part is, what do you do with that to be effective? One interesting side note, we were talking about Tommy John. There's a surgery named after him. We posted that picture of us going to the game, and
Yeah.
Tommy John actually commented on the post about Moneyball and how Oakland was doing it long before Moneyball or Billy Beane came in. But it's all, yeah. So that's the next challenge is
Yeah. But also,
injury and
The other thing
mechanics.
too, though, I mean, I think the other thing too is like, I didn't know this until I started working with Ari, is you can't have any electronics in the dugout. So as those mechanics are kind of like going along and understanding what those mechanics actually look like, you're still going to be relying on kind of like the humans or different folks that are in the stadiums to understand if the mechanics are failing, let's say, over the game in order to make a game time decision or what that looks like. So that way they can go back and work on it again.
But also the mechanics, right, outside of baseball, right? I used to do athletics. So you'd have like the biomechanics, the perfect sprint, how you do the perfect start, but everyone's different, right? So there is a general concept of the best way to sprint, about how you lean forward, your posture. But if you saw Michael Johnson, a coach would say, if he was a kid, do
Arch
not
back.
run like that. Arch back, very upright, totally wrong way to sprint. And he redefined sprinting at that stage before Usain Bolt. So you'll always get outliers. You can get pretty good mechanics, but you got to be aware that just because you have that, it doesn't mean that this person who looks a bit funky. I think in Moneyball it was Hattenberg, was it?
Mm-hmm.
Who had like the most unorthodox pitching style ever, but it was effective. So just got to be remember that.
It's much more relative to your own mechanics and fixing your. I'm struggling. I'm throwing the ball high in the end and over and over and over, and now they come out. If they can quickly get it fast enough, they go, okay, well, your approach is too lean back. You need to get more forward. Your pitching coach could make your adjustments inside of the game as opposed to having to wait till.
That's right.
Yeah, and the game, in every sport, games evolve, right? So if you look at rugby, right, it used to be the bigger you are, the harder you are, that's it. Get bigger, get stronger. And now if you look at the All Blacks who are dominating, they're all light and they're all quick. So they're much more agile. So, at one point the game is the Northern European teams and everyone bar the All Blacks was like, get big and get strong. That's the way to do it. That's how you build a team. And now they've kind of gone away from that. And they have the agility and the ability to run a big team all over the pitch and kill them. And after 60 minutes, they die, and the All Blacks run riot.
And that's a great point, is that what the way you don't want to do it is to aggregate everyone together and say the general rule is keep your elbow up, or general rule is use your hips first. And some of the biggest honors was me. I look more like a business person than a professional athlete, but I've been coach to Kerry Wood, the great Cubs pitcher, and then Cal Ripken, which what you said totally brought it up, is back in the late 80s, early 90s, they would have people look at data and give a general report. This pitcher throws fastball down and in first. And what he told me before I helped coach him was that he would be polite, like he didn't want to upset the general manager, and just kind of put it in the trash can or ignore it, but don't really ruffle feathers. And the reason he did that, he goes, people pitch to me, Cal Ripken, different than they do to other people. And so I said, okay, let me make a personalized expectancy of how a pitcher will pitch to you. He's a taller guy, he has certain strengths, and so it was very helpful to him. So same thing with mechanics is don't do anything in general. It's to the individual person, which is sometimes hard to do, but that's the only way to make them effective and actionable.
Yep.
Have you experienced much skepticism from players, coaches, other people?
Never. No.
Obviously you do, but how do you address that and prove that this will help them or make money, depending on what their position is?
So the answer to the first thing, yes, I've suffered through many decades of hostility and skepticism, anything and change from everyone in the organization. But as long as you get one person on your team to buy in and start proving value, then in a way it's better if teams that are not on your team aren't doing it, since you have a competitive advantage. And there's a whole psychology. I like to start by not saying, here, the computer printout said, do this or that, but to just go and say, where are your struggles? And they go, there's one player, we don't know why he's struggling, but he is. And then so they don't understand why something's happening, and I just focus on that, give them something actionable, and then they buy in. But it's broader than just me. We're talking about new trends. So defensive shifts, not everyone is doing them now, but the evidence shows it's extremely helpful, and it doesn't cost anything. You're just moving, pre-moving where the people are standing. And there's a great book called Big Data Baseball about the Pittsburgh Pirates. It took them over 2 years to convince the manager, the coaching staff, Hurdle, those guys to implement it. Now, and then in football, to go on 4th and 1 makes sense, but people are reluctant to do it. Now, Tampa Bay is trying this this thing where they don't, they have someone pitch 1 or 2 or 3 innings at the beginning, someone else pitch the next 2 or 3 innings, and everyone says that that's the dumbest idea, and they got hostility. And if you can guess which team has the lowest earned run average in the first inning, it's Tampa Bay. So now next year more teams are going to do it. So yeah, there's a lot of resistance and
So there's a good podcast, I think, is Sports Techie, and one of the things they said is the reluctance is if a player, they're scared about all this metrics in that it might be able to be used against them, especially when it comes to contract negotiation, whatever. But that's kind of the bad way to look at it. But if you're an athlete who wants to do well, you could be like, what information can you give me to be better? Do you know what I mean? How can you improve me? Or if a coach benches you because, I don't think you're playing well, if you have the metrics to back up and say, well, hold on, I am playing very well. Look at all the game breaks I have. Look at my average speed is quicker than every forward on the pitch. It can actually be used to your advantage. If you're struggling, yes, it may really highlight that, and that's not a good thing. But if you're a really good athlete, you want to learn from that really quickly, improve and come back stronger. So, but there is reluctance. But you gotta, good managers will always get around that.
Yeah, so that
Sorry to interrupt. We're 15 minutes over. You can feel free and chat and ask questions, but we do need to clear the room by 6 o'clock.
okay.
Thank
We'll
you.
go to the hallway then.
Yeah, we can
I'll take this
outside.
outside.